Adrenaline has a reputation. People say it slows time, sharpens reflexes, unlocks hidden speed. Stories of superhuman reactions show up everywhere: accidents, sports, emergencies. But here's the uncomfortable truth. Adrenaline doesn't make you faster, it just makes you feel faster. To understand why, you have to look beneath the emotion, into biology, physics, and the hard limits of how signals move inside the human body. When something unexpected happens, your reaction begins at the senses. Light hits your retina, sound vibrates tiny bones in your ear, pressure activates receptors in your skin. That information becomes electrical signals traveling along nerves. Even at their absolute best, human nerve fibers transmit signals at roughly 100 to 120 meters per second. Many are much slower. That's not a training issue, it's a physical constraint set by ion movement across cell membranes and the structure of axons. Electricity in a copper wire moves near the speed of light. Ions in biology crawl by comparison. Once that signal reaches the brain, it doesn't trigger action instantly. It has to cross synapses, microscopic gaps between neurons. Each synapse introduces a delay of roughly half a millisecond to a full millisecond. A simple reaction involves several of them in series. Those delays add up fast. That's why visual reaction time for humans clusters around 200 to 250 milliseconds. Auditory reactions are a bit faster, often around 150 milliseconds. Touch can drop closer to 120 milliseconds. These numbers barely shift even in elite athletes, fighter pilots, or people flooded with adrenaline. Adrenaline does not remove synapses. It does not make ions diffuse faster. It does not change the speed of neurotransmitter release. Those processes are governed by chemistry, not willpower. Even after the brain sends a motor command, the job isn't done. Muscles don't move the instant they receive a signal. Calcium has to be released inside muscle fibers. Actin and myosin filaments must form cross bridges. Force must build up. That excitation-contraction coupling takes on the order of 30 to 50 milliseconds. No hormone can compress that to zero without tearing tissue apart. So where does adrenaline come in? Adrenaline prepares the system. It increases heart rate and blood flow. It mobilizes glucose for instant energy. It raises baseline muscle tension so fibers are closer to firing. It suppresses pain and hesitation. Most importantly, it changes decision-making. Under adrenaline, the brain stops waiting for confirmation. It commits earlier. It guesses more aggressively. It skips safety margins. That's why reactions feel instant. You're not reacting faster, you're acting sooner. Athletes under pressure often move before a ball is struck. Drivers slam brakes before fully recognizing danger. Soldiers fire before consciously processing every detail. These aren't faster reflexes. They're predictions made with confidence. Laboratory tests prove this. When reaction time is measured precisely, adrenaline narrows variability but barely shifts the minimum time. The floor remains the same. The spread tightens. If adrenaline truly broke biological limits, we would see consistent sub-100 millisecond visual reactions in humans. We don't. Not in combat, not in elite sport, not in emergencies. There's also a cost. Adrenaline increases error rates, it increases false positives, it makes you commit to wrong actions faster. Evolution tuned adrenaline for survival, not precision. That's why machines outperform humans in high-speed environments. Autonomous braking systems react in milliseconds. Missile defense computers respond faster than any pilot. Financial markets run on algorithms because human reflexes are simply too slow. No amount of adrenaline bridges that gap. The limit isn't mindset. It isn't courage. It isn't discipline. It's neurons, synapses, and muscle physics. Adrenaline sharpens the blade, but it cannot make it cut faster than biology allows. Humans don't break reaction time limits under stress, they just gamble sooner, and hope they're right. Subscribe for more mind-bending science facts.